Hello students, today here I am with you with a very new topic, hybridization. You know what is hybridization? According to valence bond theory, the covalent bond is formed by the mutual overlapping of two pure atomic orbitals of the constituting atoms. But that theory can only explain only the simple molecule like H2, Cl2, HCl, but it fails to explain the molecules like CH4, ammonia, water and large number of organic compounds. So a new concept came, that is hybridization. The concept of hybridization can best be understood by taking some simple examples. And let us start with a very simple organic compound, methane. Let's begin. Methane. Do you know the electronic configuration of carbon? Carbon atomic number 6 and the electronic configuration is so in the valence shell how many electrons are there? 4 electrons are there. And if you see minutely, you will see two electrons are in the paired form and 2 electrons are in the unpaired form. So apparently it seems the valency of carbon may be 2, but actually in all the compounds the valency of carbon is 4. And do you know how? It occurs due to the excitation of these 2s electron to 2pz orbital. And you know 2s, two px, 2py, 2pz. So it is the ground state electronic configuration of carbon, ground state GS. At the excited state, one electron from the 2s jumps to 2pz orbital and making the unpaired electron 4, and that's why the valency of carbon is 4. So if these electrons are to form methane, then what will occur? As you know, these 3 electrons having same energy, 2px, 2py and 2pz, but the 2s electron having energy less than that of. So if methane is to form, 2s, 2p, 2p, 2p. So these are the 4 electrons contributed by carbon, 3 2p electron and 1 2s electron, 1 2s electron. And if these electrons overlap with the hydrogen, so methane can form 1s. These are the 4 bonds formed by methane. But here you will see the 3 bonds should have equal energy, 2p1s, 2p1s and 2p1s. But the one bond is 2s and 1s. So that bond must be weaker. But experimentally it has been found the bond energy for all the bonds same. And how it may happen? And that can only be due to certain reasons, and that reason has been found to be hybridization. In order to explain experimental facts of bond dissociation energy, bond length and bond angle, it has been suggested or it has been assumed that there is a distribution of energy in between these orbitals. And as you know, the s orbital spherical in shape and 3 p orbitals having dumbbell shaped. So 2s orbital, 2s atomic orbital, 2px, 2py and 2pz atomic orbitals. And these orbitals, these are the atomic orbitals having same energy, but the energy of the 2s orbital is less. Now there will be distribution of energy in between these four, and to form four equivalent atomic orbitals, and the name of the equivalent atomic orbitals would be sp3. Neither s nor p, it will be sp3. 1s and 3p combined to form four sets of new atomic orbitals, and those will be hybridized orbitals. Those will be hybridized orbitals, and those are said to be sp3 hybrid orbitals. Carbon being at the center, four hybrid atomic orbitals of carbon lies at the four corners of a tetrahedron, and it can be shown as so carbon is at the center, and the four hybrid orbitals sp3, sp3, sp3 and sp3. These are the four sp3 hybrid orbitals. These hybrid orbitals equivalent in their shape and energy. And now four hydrogens s orbital can overlap with these sp3 hybrid orbitals to form methane, and it can be shown by so the structure of methane is like that, and the bond angles are found to be 109 degree 28 minutes. And do you know why such angle? Actually, these are made up of with electron cloud. So electron clouds are tries to far apart from each other, and mutually the maximum distance that can be achieved is that one. So that is the structure of methane.